Go.
Hi, I'm Lash Pelican.
I'm Kevin Ducray.
And I'm Draco Leonard.
This was Lab 1 and we're Section 5, Group B. I'm Lash Pelican. This is our lab setup. Currently it's set up to test the flatness of the rail as compared to the table. To do that, we used a pentaprism to deviate the beam 90 degrees down into this petri dish of water. The beam was then retroreflected back up and to the laser cavity. If the table was flat, the beam would have gone back in the cavity, but it's not perfectly flat, so you can see the beam on the laser surface over there. And that's the water moving around. And to align the beam to the rail, we use this iris, and we move the iris along the rail to check beam alignment. And when the beam was aligned with the iris, the beam stayed within the center of the iris the whole rail length. Here we have our setup to check the levelness of the table. We used a pentaprism to deviate the laser beam 90 degrees down into a petri dish of water, where the beam was then retroreflected back up and to the laser beam. You can tell that the table is not level because the beam is not being shot back into the laser cavity.
After we had the setup completed, we checked the alignment by using a cube beam splitter to create an orthogonal setup for the ray, using also this extra rail and the iris over there. We did that by first tipping and tilting this so that the pentaprism, or the cube, so it would go back to the laser, and after that we moved it along the rail, and then tip and tilt again so it would go back to the iris until it was aligned properly. The pentaprism is a lot easier to align due to the fact that there's one less axis to worry about.
What's the key for?
Because
It's 90 degrees.
Hello, my name is Kevin Ducray, and for the last part of the lab, we had to align both the green and the red laser at once. In order to do this, we set up the green laser right here. We attenuated it with a polarizer. Set up the pentaprism, the cube, and the idea was to get the this laser reflecting back into the laser cavity by reflecting it off this cube, and then from there we didn't touch that at all. We adjusted the Z direction on the pentaprism, and then we just did a tip tilt in order to align it close and both far away, and we got it aligned.
Wait, go. For this part, we aligned optical elements with the laser, which was aligned to the rail. To do that, we saw the back reflections from the surface, the front surface and the rear surface of the lens, and they were sent back to the laser into the cavity. And once both reflections were in the cavity at near distance, and it was constant all the way when we brought the lens out, then the lens was aligned. And then for the next part, we made a Galilean telescope. So we used the 1000mm focal length right here, and we used a -25 right there, and we separated the lens by the separation of their focal lengths. And the output, we see that the beam is fairly collimated, and that's what a Galilean telescope is supposed to do.
So for the last part of the lab, we aligned the microscope to the laser, and so for this we had to get the beam, the crosshairs both aligned with the crosshair on the screen, which was originally the crosshair of the laser. So when doing this, when you adjust the rotations, that moves both the crosshairs and the beam, and so the idea is to get the crosshairs aligned with one another, and then use the X and Y tilt to adjust the beam in the correct position. And once then, it's aligned.
Go.
Hi, I'm Lash Pelican.
I'm Kevin Ducray.
And I'm Draco Leonard.
This was Lab 1 and we're Section 5, Group B.